Welcome to the tutorial on WiDS Datathon 2022. This year's WiDS Datathon focuses on energy consumption prediction. Before getting started with the technical implementation of the competition, let's look at the context and the background behind the competition. Climate change is one of the global causes, and United Nations has also identified tackling climate change as one of the 17 goals for 2030 Agenda for Sustainable Development. According to a report published by international energy agencies, around 37% of the CO2 emissions has direct correlations with the life cycle of buildings, which includes the amount of heat and electricity consumed by these buildings. So if we can estimate the amount of electricity and heat consumed by buildings, then it's also possible we can use certain strategies to bring this amount down by 50 to 90%. So the goal of WiDS 2022 Datathon is to use building characteristics and the weather-related information to predict the amount of heat and electricity which buildings consume. The data set which is given to us is being prepared for over a period of 7 years, and it contains around 100,000 rows. And it's been collected from number of states across the United States. So we're given 3 files. One is the train CSV file, test CSV file, and sample submission CSV files. The train CSV file is the file in which we need to train the model on. And the test CSV file is the file where we will evaluate the train model on. And sample submission files contain a sample format on how you should make submissions to the Kaggle competition. So when it comes for the columns, we have a combination of building related characteristics like the state factor, which tells which state the building was located on. And most of the states are anonymized. And it also contains the kind of building, whether it's a residential or commercial, and the facility type, whether it's a warehouse or educational institutions or a grocery store, and the other specifics like floor area and the year in which the building was built on, and more importantly, the Energy Star rating for the building. In addition to the building characteristics, there are also weather-related information like the minimum temperature, maximum temperature, and the average temperature across all the months. And you also have the annual precipitation degrees. And you also have, the number of days it was below a certain temperature. And you have details like, the days in which there was fog and the maximum wind speed and the direction max wind speed. So using all these building characteristics and weather-related information, the goal here is to predict the amount of heat and electricity consumed by buildings. So the target variable is site, SITE_EUI. So the evaluation metric given to us for this competition is root mean squared error, which is the square difference between the actual value and the value predicted by the model. Now heading on to the technical implementation of the competitions, we will start by importing all the open source Python packages which we require for the implementation. So we require NumPy for array manipulations, Pandas for manipulation of tabular data, and we also will be using a package called scikit-learn, which contains the implementation of most of the machine learning algorithms. For this baseline implementation, I'm going to use LightGBM. You can also use Matplotlib, Seaborn, or any other data visualization libraries. You can use SHAP for machine learning model explainability and interpretability, and Optuna for hyperparameter tuning. Pandas is a data manipulation library which comes with a rich set of features and methods to manipulate and deal with tabular data. So I'm using the Pandas read_CSV method to convert the CSV file into a Pandas data frame. So I'm converting both my train and test data into a Pandas data frame. And Pandas has attributes like shape, which gives me the number of rows and columns in my data set. So I have around 76,000 rows in my training data and around 10,000 rows in my test data. And I have 64 columns in the train and 63 columns in the test data. So there's an extra column in the train, which is the target variable, which is site_EUI. So I can use the head method from the Pandas to get a glimpse of my data. So I'm using a head on the train data frame. So now I have the first few rows of all my columns. So here I can see this is site_EUI, which is my target variable, which denotes the amount of electricity and heat which is consumed by the buildings. This is the variable which I need to predict. And the remaining features are going to be my input to my model. And there's one feature which is ID, which is just a sequence for each of these rows. So this is one feature which we will be dropping because it doesn't give any information. It is just a sequence of numbers. So the remaining features are going to be my input to the model. So if you see, there are three features which are categorical features, which are state factor, building class, and facility type. So state factor is a state in which the buildings are located. All states are anonymized. And the building class is of two categories. One is commercial and residential. And finally, facility types. There are a lot of facility types under this column, and it can be anything like grocery store, retail mall, education center, and all that. So the remaining features are mostly numerical values. So if you see, there are some missing values here. So up next, we will see how many columns from this data set have missing values. Most of the real world data comes with a lot of errors and missing values. And so it's a very good practice to explore the amount of missing values in your data set at the early stage. Here, I have used a heat map to visualize the missing values in my data set. So I can see some pink patches here, which denotes the missing values in my data set. On a closer inspection, I can see the fields and the corresponding number of count of null values in each of these fields. So there are around 6 fields which has missing values. During the pre-processing stage, we'll be looking at how to handle these missing values. Now heading on to the other part of exploratory data analysis, you can use describe method to get some basic descriptive statistics about the data set, like mean, standard deviation, minimum value, maximum value for each of the 64 columns. Exploratory data analysis through visualization is a great way to detect outliers or any abnormal distributions in your data set. Let's begin our visualization with target variable. So the target variable here is site_EUI, which is the amount of heat and electricity consumed by buildings. So let's do a simple KDE plot to see the distribution of a target variable. We can also use, I've also used box plot. So this will give me if there are going to be any outliers in the target variable distribution and what is my median value, what is my quartile values in all these statistics. I've also used a probability plot from the SciPy package, which gives me a better understanding of the target variable distribution. Similar to exploring the target variables, we can also explore the numerical variables. Here again, I have used KDE plot for visualizing the numerical variable. And I'm taking each and every numerical variable and I'm exploring the distribution of this variable in the training data set and the trace data set. With the exception of few, most of the variables have got similar distribution in the training and test data set. After visualizing the numerical variables, I'm heading on to the categorical variables frequency distribution. As I said earlier, the state factor denotes the state in which the buildings were located. So here there are around 11 states. This is a frequency plot on how frequent a particular state is. And the second categorical variable was building class, which denotes the kind of building, whether it's a commercial building or a residential building. This is the frequency plot showing us the frequency of occurrence for commercial and residential plots. Again, the third categorical type is the facility type. What kind of building it is? Was it a mall or an educational institution? So you can see there are particular facility types which occur the most, and few almost occur very, very few times. You can also try other visualization techniques, like you can see the distribution of numerical features with the target variables. You can explore the correlations of features through heat map, and you can try out density maps. As a part of pre-processing technique, I'm going to remove my target variable from my training data. If you remember, as I said earlier, the training data contains 64 columns, which also includes the target variable. So to train my model, I need my target variable in a separate input variable. So I'm taking it and storing it in a variable called target. Post that, I'm going to drop both my target variable and the ID variable. ID because it doesn't have much significance, it's just a sequence of numbers. Similarly, I'm going to also drop ID from the test data set as well. Before you start modeling, it's very important to do a certain pre-processing techniques. I'm going to cover the very basic pre-processing techniques here. Missing value imputations, as I discussed already, is a very, very important pre-processing technique, which has a huge influence on the quality of the model which you develop. Not many machine learning algorithms can handle missing values on their own. So it's important to handle these missing values if they occur in your data using strategies and techniques like mean value imputation, median value imputation, or you can impute using the most frequently occurring items, or clustering techniques like KNN, or techniques like mice. Here I'm going to use a very basic technique called mean value imputation. Except for the field year built, I'm going to impute all other fields using mean value imputation. For the variable year built, I'm imputing here by 2022. You can impute it by maybe the most frequently occurring year or previous year, 2021. And the next technique we're going to see is the label technique. This is again a very, very important technique. Not many machine learning algorithms can handle categorical variables on their own. So it's important to convert the categorical variables into numerical variables. Some of the techniques to do this are label encoding, frequency encoding, and you also have one-hot encoding. Here I'm going to look at label encoding, that there are many other methods to do this process as well. I'm going to use the scikit-learn implementation for it. The label encoder is a method from scikit-learn, which helps me convert the categorical variables into numerical variables. So I'm creating an object, then calling the fit transform method to convert it from categorical to numerical variables. The third technique which I'm going to cover here is the feature scaling. Feature scaling, again, is a very important pre-processing technique because most of the data in the real world are in different scales and ranges. For example, height of a person might be different. Or in this context example, which we are looking, temperature is measured by a different degree. And building fluid width is measured by a different degree, and building characteristics might have different scales and ranges, and weather-related data might have different scales and ranges. So in order to build an efficient machine learning model, it's important to bring all our input or features into a uniform scale. This process is called feature scaling, and there are many techniques to do this. One of them is standardization, the other one is normalization. Standardization is a process where I center all my values around the mean with the standard deviations of 1. So to do this, I'm going to use a scikit-learn implementation here, which is standard scaler. So I'm going to create an object similar to previous example. I'm just going to call the fit transform method to do the feature scaling. One of the very important part of the model building process is to get the best hyperparameters for your model. We can achieve this by using any open source packages. One of the open source packages, Optuna, which helps us find the best hyperparameters for the machine learning algorithm we are using. So here I'm going to use LightGBM module. So there is a corresponding method called LightGBM tuner CV in Optuna, which I can use for finding the best hyperparameters for LightGBM. Once I do a training using this LightGBM tuner CV, I can get the best parameters from best underscore params attribute. So LightGBM is a gradient boosting framework based on tree-based learning algorithms. And it's one of the algorithms which is most frequently used in machine learning algorithms. And I'm going to train my LightGBM module once again with the best hyperparameters I got from the best underscore params. After training my model LightGBM, I can also use the LightGBM module feature underscore importance attribute to get the list of features which is predicted, which is contributed the most to the machine learning prediction. So here I can see the list of features which has the highest contributions towards the prediction, like the facility types, the year it was built, the Energy Star rating, the floor area, the building class. So if you see the building related characteristics have the highest influence on the amount of electricity which the building is consumed. And the weather related characteristics have lower influence on the kind of amount of electricity the building is consuming. And there are also certain features which do not contribute anything at all, which is zero contributions. And for the sake of simplicity, I have removed those features from the plot. You can do the same thing using another open source package called SHAP. It's an open source Python package, which gives you the same details. This is a SHAP plot, which tells me the features which has contributed a lot towards the predictions and features which had zero prediction. So you can see direction of wind speed and the maximum temperature number will all have zero contributions to the final machine learning predictions. And finally, I'm going to do my predictions on the test data. And once I do my predictions, I can convert these predictions into a CSV file, again, using Pandas read_CSV file. And the file format, final submission format, has to be in line with the sample solution format, which is being provided in the competition. Finally, I'll head on to my data section, where I'll be able to find my submissions.csv file. And I can make a submission to the CSV file by clicking on the submit button. A pop-up will open where it will tell you the notebook which you're using and the particular version and this corresponding CSV file. And when you click on the final submit, your solutions will be submitted to the competitions. You can view your submission here. It gives you the score, and you'll also be able to see multiple other submissions here, but you'll be able to choose only the most important, you'll be able to choose only a couple of solutions which you think is the best, the final competition. And this is a basic walkthrough of WiDS Datathon 2022 challenge for the energy consumption prediction. This is just a baseline model, but there are a lot of improvements which can be done to this baseline solutions. There are various feature engineering techniques which can be tried, and there are also various feature selection techniques which can be done. And finally, not to forget, ensembling techniques have always proven to be the winners when it comes for Kaggle competitions. We've come to the end of the session, and I'm wishing everyone all the very best for WiDS Datathon 2022. Happy Kaggling.